Alright, time for another DraftPhysics.com video presentation. So I'll deal with some comments by the trolls. I did interact with them a little bit, but I'm not going to continue that really, and so I'll just make a video explaining why, frankly. They just keep evading the subject, which is how this whole kinetic energy thing started, with a misunderstanding by Leibniz of this simple principle that when you drop things, they go faster because of energy they've already gotten from the force, and they don't get more energy. So it's like if I throw a baseball with 90 miles an hour, and then you decide to push it with an extra mile an hour. You can't change the 90 miles an hour. What you've acquired already is already built in, and you can only add to that. And that's all this force of gravity can do, is add to something. So it adds 1 unit of force in 1 unit of distance, but now it gains 9.8 meters per 1 second. So it gains 9.8 meters of velocity, and it will keep that theoretically forever until it meets a counter force of some kind. And each time the force pushes, it's just pushing with 9.8, and you end up with twice the velocity down here, 19.6 versus 9.8 here. And this experiment here is essentially the same as this little experiment here. These two are the same thing. And this big giant thing here is actually the same thing, the same amount of time, and it's the same amount of force that was added. And it just looks bigger because of the accrued velocity. And so all it is 2 units of force here. That's it. 1, 2. 1 here, 2 here. 2 units of force doesn't equal 4 units of energy. And so this whole 1/2 mv squared is just based on this misunderstanding of something very basic, that gravity isn't a distant dependent force, it's a time dependent force. And that simple argument hasn't been countered by anybody or logically explained how, no, 2 units of force does equal 4 units of energy. There's no explanation. So that's the context and such. So to the comments, one hopes that looks like them. Alright, so I haven't looked at this for a little while. See 18 of them. And so the Ian Gosling guy says, what are you saying? Half maximum velocity at 3/4 the total distance? Yes, exactly. I've explained this maybe 3 dozen times. It has the same rules for rolling something. You roll something, doesn't matter what the distance is, doesn't matter how far something falls in gravity. This thing over here, when it falls this little short distance, it's doing exactly the same thing. It's 1 quarter, at 1/4 of the drop, it's already going half the velocity. It happens no matter what you drop in gravity, no matter what distance, you can always find this 3-to-1 relationship every single time. And the same is true for friction, rolling friction. So I've explained that over and over and over. So I explained it's not very complicated. When you're opposing the force, okay, you go half your initial speed after traveling 3/4 of the total distance. So when the force, the constant force, interpreted through friction, is opposing you, okay, forcing you to lose your momentum, then yes, at 3/4 of your trip, you'll go half your velocity. And if you're being pushed by the force, if it's pushing you, then exactly the opposite is true. You go half your velocity after only 1/4 of your trip. Alright. So, and then he asked, when am I going to admit the simple experiment launching masses off a table measuring landing distance? Again, the measuring of landing distance is the same as measuring the velocity. So you're just arguing that something half the mass can't be pushed at twice the velocity, that the momentum isn't conserved. So something as fundamental as conservation of momentum, where theoretically you can think of it as one atom going 1,000 miles an hour versus 1,000 atoms going 1 mile an hour, and you're going to understand you always have to account for these numbers. You can't just make them disappear. I can add 2 atoms to the one that has 1,000 miles an hour, and I can understand that 2 atoms would be 500 miles an hour, and 3 atoms would be 333 miles an hour, and 4 atoms would be 250 miles an hour. It's not any more complicated than that. So you're making a bold assertion that momentum isn't conserved. I'm saying I think it has to be. All right. In your recent response, so this is the Falwell fellow. In your recent response, you still persist that 4x the height only doubles the weight on impact. So, of course, that's all it does. That's Ian Gosling agrees with that. And I'm like, come on. They can't even get their own argument straight. So, and then the Ian Gosling says about when I'm going to admit it, and I say, well, you know, when Brozo admits 1911 is close to 2 to 1, and blah, blah, blah. So, it goes on and on like this, and then, you know, the Falwell guy keeps arguing that 4 times the height equals something other than twice the velocity, which is really stupid. And so I just keep pointing out, you just keep talking rubbish as usual. You could ask your own troll friend what he thinks, and he'll explain it to you maybe. And then we go back to the experiments. I just point out we have all this conflicting evidence. Gosling says his experiment proves this. Brozo says this experiment proves that. I say Brozo's billiard ball experiment is a pretty good piece of proof. And then my own, of course. All right, my own lever experiment, well, catapult. So, and then I point out, look, one of my clearly made arguments is that you are respecting dogmatic fables not investigated as facts. And again, they made this conspiracy argument, as if I'm claiming a conspiracy, when I've said that the only thing I'm claiming is the conspiracy of stupidity and idiocracy. That scientists don't really know what science is supposed to be, which is you're supposed to be collecting evidence and then presenting a very clear and decisive argument in defense of that evidence, where the evidence is pointing. And they're doing the opposite. They're drawing a conclusion and then saying, how can we contrive evidence to fit our conclusion? It's not what science is supposed to be. So I challenge him to explain why the Eddington experiment hasn't been redone, when it's so easy from space, and it's so much better, and it's such an unanswered, critical question of intense importance that should be clearly proven. All right. So, and then he says, I strawmanned him by, I don't know, doing what? The word respect here is an effort to score points. I don't know what the simple argument is clearly you're respecting what I'm calling crappy science. You're saying it's respectable, so much respectable that I'm not allowed to argue against it. I can't make any of these logical arguments. I can't claim that gravity is a time-dependent force, because they have so much evidence proving it's just how far you travel in gravity. It's not about how much time you're in gravity. When I'd say, no, they don't have any evidence basically defending their position. Nothing shows that to be true. And again, they can't even show you the simple things like showing how it takes 9 times the gas to go 3 times as fast. That's what their theory says. Do you believe it? I mean, shit, you're talking about a straw man? And then the added bonus coming back around to accusations of religious blind faith nonsense. Well, I think that's all you have, because you don't really even understand the physics. But clearly that's all this is, right? This wave particle crap, this superposition, this entanglement shit. This is all crap people want to believe. It's not crap proven by evidence. You don't think there's any such thing as a non-moving object in the universe, because nothing is real, frankly. I mean, it really can't be a real universe if relativity is true. It's just so nonsensical. Alright, some have actually tested these things for themselves. So again, this nonsense about some sort of tested for yourself, in what way and how, and in what way is it all decisive. I mean, it's just bullshit. I'm saying, go ahead, show me something decisive, not something obscure. Show me something decisive. Show the pouring the 9 times the fuel into the gas tank. so polar opposite to any religious type belief about it at all. So I'm just saying that obviously the absence of evidence is pointed out by the lack of ability to even, the lack of will to even redo the Eddington experiment. I mean, the fact that physics hasn't done any of these pendulum experiments, they haven't done any of these lever experiments, they haven't poured gasoline into an engine to see how far it goes, they haven't done any of them. That's exactly religion. Amazing that he would say tripe like that. I would think, like any other professional in the world, there are good and bad science doers. So again, I'm just saying, point me to one, all right? Point me to somebody who isn't arguing from their faith position, because frankly, I'm going to say that's all they have, because they don't have evidence. But they can't all be that bad if you get my meaning. Well, says you. I'm just saying that they're not trained to understand their obligation. I mean, this science thing, again, is sort of just an integrity thing. It's sort of like being a good lawyer. Some people believe lawyers are supposed to get their clients off, when, no, what they're supposed to do is defend the truth. That's what they're always supposed to do. And so if an evil prosecutor is distorting the evidence, well, yeah, the lawyer should fight that. But if the prosecutor's telling the truth, then the lawyer should just say, well, too bad my client's guilty. Okay? But his job isn't to come up with shenanigans and cheat and lie to get his client off, do a performance. That's what physics is doing. They're doing performance art, and you can see it. It's all over the documentaries they produce. It's all about graphics and pow and wow. It's not about any kind of logical, reasoned, disciplined argument. It's all about how fascinating it is. How, not understanding is the most fun ever, and blah, blah, blah. It's all a bunch of hypey talk. Okay, Gosling says, you're clutching at straws. So again, no, you are. Okay, frankly. Your desperation is showing, because you can't produce a single link to any credible physics experiments. Okay, you're having to resort to the crap you can engineer in your shed, your garage, whatever. And then you're going to defend the science as being complete and well processed, when obviously it's not well performed science, because you can't link to anything. Regards Steve's 911, you know full well why the half mass achieved a higher velocity. So this is just their made up excuse. Okay, so the heavier mass made maybe one rotation. So he says that all the 0.6 worth of the momentum was caught up in the one rotation of the billiard ball, which is just bullshit. It's been well documented. Nothing's been documented. How did you document it? Brozo didn't even count the rotations. He didn't count what the angular momentum would be. He doesn't even understand angular momentum, because he did a second experiment where he did it with hollow and solid objects, not even understanding that. And instead of releasing them at the same time, he lifted the table, which is also bizarre. Okay, in the full mass, the energy of the launcher went to both rotation and linear motion. So again, you don't have any evidence that any significant amount of energy went to rotation, because I would argue you can visually see the rotation is way behind the actual distance the ball traveled. So it's not rotating anywhere close to the actual speed it would if it was making good contact. So again, it's just a bullshit answer. You're just making this crap up. Okay, in the half mass it slid, so all the energy went into the linear motion. So you're arguing about something you don't know anything about, because you don't even know how much the sliding actually has to do with the fact that maybe he didn't hit the balls on their center of mass, and he actually gave them some backspin, technically. So it went much quicker. So again, doesn't account for it. You haven't explained how it can account for it. So even if the heavier ball actually did rotate and the lighter ball didn't rotate at all, you still haven't demonstrated that would be enough energy in the angular rotation to consume so much of the velocity. You well know this. So again, I don't well know it. You haven't demonstrated anything. And in your poorly conducted demo, you clearly state there is no need to measure. So again, where did I state this? I'm just saying that I did my demo. I didn't claim my demo was entitled proof, like you morons. You've titled 17 videos proof that you've retracted, you fuck. All right. I mean, it's just such obnoxious crap coming out of your mouth. Did my video say proof in it somewhere? No, it didn't say that at all. It's a counter argument to your statements. Okay, so as far as I'm concerned, it's a visual experiment. You want to analyze it and prove something, go ahead and do that. All right? And all I said was, this is how far I've gotten. This is my draft experiment. Then I pointed out some of the flaws I recognized, and that's why I want to go to equally sized round objects instead of the steel bars. So I have to wait to finish the experiment. Now, we also have the other lever experiment being done by PhysicistMichael now. We don't see any of that yet. But why don't you wait till you see those results before you type all this crap, frankly. Alright. Even so, it can be clearly seen from the dual screen comparison the full mass lever accelerates faster than the half mass lever. What a pile of absolute crap. Sorry, not even close. And actually gives the 1.4 you persistently deny. So, whatever. Dream on. You want to try to pretend, okay? The fact is that, I mean, you can see from the video, the small mass's center of mass moves twice the distance in the same amount of time. They both end up at the finish line at the same time. One swings out, the other one swings out. They both end up at the same place, and one travels twice the distance. So, bullshit on you. So anyway, again, in your recent short video, twice the height given twice the velocity. Why are you keep saying this? Again, I asked you to go ask Ian. I mean, Ian, he told you, Ian, he said in his own video, okay, that we agree that 4 times the height is twice the weight. Okay, twice the velocity. Why are you arguing the point? Again, in your recent short video, twice the height doesn't give twice the velocity. Yes, you have to go 4 times as high, which no one says it does, by the way. I'm sorry, the guy was making a comparison. Are you talking about the water video now? The electricity video? He was making the argument that all you have to do is lift something twice as high for it to have twice the voltage. Okay, and voltage was being compared to velocity. Obviously, you won't get twice the velocity. Okay, so by the way, see, you don't understand. I mean, I'll just go back to my other comment. You're just a recklessly stupid person making comments, and you don't even understand the theory you're arguing. I mean, why don't you make this comment on that video? Oh, that's right, you don't get lost in the 4 million other comments on his video. But, it's just so stupid because you're just plainly wrong. He's making a direct comparison between voltage and velocity. And then says something as stupid as, look, you go twice as high, you get twice the voltage. No, you don't. I've made the mistake in the past, obviously. You make the empathetic statement that it doesn't work this way. Emphatic statement. Yeah, gravity doesn't work that way. He was literally talking about lifting an object and rolling it down a hill, you moron. Obviously, you don't get twice the voltage, twice the velocity, okay, just lifting an object twice as high. Damn. You provide no proof. What? Apart from illustration on your whiteboard. Yeah, illustrations are really good, frankly. Why don't you try doing one? Okay, whiteboard, and the assertion that it's all wrong. Everybody knows it's wrong, okay? I'm just saying he made a mistake. It was wrong to imply that twice the voltage is twice the height. No, it isn't. Which is fine, but you show your reasoning. It's in every fucking video. I can't believe these. See, this is why there's no point in talking to these morons. Every fucking video I make has the reasoning in it, you fucking idiot. I explain why I can't believe what you believe. 2 units of time, 2 units of force. You're saying that's 4 units of something. I can't figure out how it possibly could be. And if I go the one step further, and 1, 3, 5, and now you're going to tell me it's 9 times the force. So it's only 3 seconds, 3 9.8s, and somehow that equals, 9. No, it doesn't equal 9. Oh, just fuck, what an idiot. Arriving at this conclusion, backed with evidence to support the reasoning. Where have you backed anything with evidence, you fucktard? I mean, amazing. Look, if you're going to drop something on a spring, you have to first figure out whether the spring works, whether within the limitations of the spring. Now, Ian Gosling almost did the experiment correct. That is, you really have to drop both objects from both heights. So you take the half mass object, you drop it from the 1 height, and then you take the half mass and drop it from the 4 heights. Then you take the double mass and do exactly the same thing. So you have 4 pieces of data. All right, now you can see if they all correlate, by your prediction. And neither one of you could accomplish that simple task. All right, claiming, let's see, evidence to support the reasoning, claiming it's a fact. Just claiming, I'm just arguing with an idiot, okay? You're a fucking idiot. I don't need to prove that 4 times the height creates twice the velocity. Twice the height doesn't create twice the velocity. That's the fact I'm claiming, and it's not a fact I should have to defend with anyone who has spent any time in these conversations about physics. Alright, just doesn't carry any weight. Okay, so just fuck you. Oh, not Brozo. How disgusting. Alright, let's see. Regarding Ian Gosling's comment, when you are going to admit the simple experiment launching masses off the table, to which you reply, your own Play-Doh experiment contradicts your claim, so that's the truth. Ian Gosling did the experiment by dropping the masses on Play-Doh, and he got exactly as I predicted, which is the half mass from 4 times the height weighs the same, okay, as the full mass from 1 unit of height, 1 unit of time in the gravity. All right, stick to the point. It is the fucking point. Oh, I don't even know if I want to read this tripe. Look at all this crap. Oh, fuck. Yeah, maybe we'll do Piro first. Piro's a moron, though. Yeah, 1 sentence. If he can convince us he's right, he doesn't really care if he is right. Amazing horseshit. Oh, god damn. So this moron Piro thinks I actually don't believe my own arguments. 2 units of force. It's a clearly time-dependent force. It's 9.8 meters per 1 second. You're going to tell me I made a mistake somewhere. Well, why don't you explain the fucking mistake, you fucking weaselly piece of shit? It's not that much here. Is there that much written on this fucking board that you can't follow along and explain where I made a mistake? It's obviously 2 units of force, retard. 2 seconds at 9.8. It ends up 19.6. It's clearly 2 units of force. You're saying 2 units of force equals 4 units of energy. I'm just asking you, why the fuck should I believe that? That's fucking stupid. Oh, these people. Insufferable. It really is unsufferable. I'm back from a bit of vacation. Anyway, dinner and such. Alright, so PhysicistMichael left a comment. So he says he won't interact with me, but he'll interact with me in this backward way, or whatever this is, or whatever. He'll do this commenting stuff, but he won't play one of my 5-minute videos and explain the errors in the video. He won't do that. Alright, so anyway, DraftScience, I think we have an opportunity here. I mean, what? So as I pointed out in the video, he didn't demonstrate anything. Okay, I mean, this is really old news. This is Galilean stuff. I mean, the falling bodies, the 9.8, okay, Newton did that. I don't know why Galileo didn't actually do it, because frankly, he was so close. Anyway. You seem to accept the experimental setup. I mean, there's nothing to the experiment. Of course, I accept what goes up comes down. I accept all of that crap, and I pointed out kind of in detail how it actually works, and you ignored that. So let me just emphasize it again. He's going to require me to do math, so I did do some math. You know, as much as I don't want to. It's not my forte. But look, I pointed out the simple Galilean truth. 1, 3, 5, 7. Keeps going. 9, 11. Okay, the odd numbers and the odd numbers create a squared relationship, a quadratic relationship. All right, so you can go by the total amount of distance. 4 units of distance, square root of 4, 2 units of time. And that's true all the way down. So by that simple relationship, this is, like I said, Galileo already figured this ratio out. This ratio gives you this answer. You just have to figure out a couple of accelerations. Once you know the difference between this velocity and this velocity, the rules basically say if you have 3 times the distance, 3 units of distance, after you've collected 1 unit of force, that this outcome is demanded, and these times will be equal. This time will be exactly the same as this time. T1 will equal T2. So even though D1 and D2, D2 ends up being 3 D1s, that already gives you these relationships, and you can play with the math either way you want to, this way, that way, that. I mean, why should I have to argue to a physicist that there's all kinds of different ways of formalizing the expression? I can write 1/2 VMV, right, instead of V squared. I can write lots of different ways. I can put take the 1/2 out and put the 2 at the bottom and go M over 2V or something. I can do it lots of different ways. So why are you pretending? Sorry, but this is just crap, frankly. All right, and the data in the video, so we can use this. So again, the data in the video is as simple as throwing things up in the air and watching them come down, and knowing that they're coming down based on a constant force pushing them, and they went up fighting a constant force pushing against them. And again, I pointed out the detail, the important detail of this 1 to 3 relationship that exists in every single one of these gravitational circumstances. Half the velocity after 1/4 of the distance. Half the velocity after 3/4 of the distance going up against gravity. In this video, which you completely ignored in your response. So again, this is just such crap. I conceded you did a mathematical equation. So what? How does that undo the stated fact that the time isn't quadratic? The distance is quadratic. That's what Galileo pointed out. The distance is quadratic. Damn. I demonstrate 2 methods. Who cares? Admittedly related. Double who cares then. For experimentally calculating, so I don't even know what that even means, experimentally calculating. Calculations aren't experiments. The value of G. You just calculate it. You don't experimentally calculate. But anyway. Yeah, so 9.8. Getting 9.8. All right, so what? Okay, I mean, so what? Let's see. And both involved meters per second squared. Who cares? Garbage in, garbage out. You put squares in, you're going to get squares out. Yeah, no big surprise. Okay, the first by taking data from the entire motion and fitting the position versus the time graph to a parabola. And again, the parabola is demonstrating exactly what I'm pointing out, which is the velocity, okay, changes non-linearly. Okay, it changes substantially as you slow down, lots of change in your velocity, and little change while you have the high velocity. All right, and using the coefficient in front of the 1 squared term to get the gravitational acceleration. So again, I I might as well point out, look, I think this works, so I'm just pointing out what I did mathematically. Okay, yeah, we don't, it's still on the board. All right, so all I'm saying is if we know V2 is just going to be 1 unit of whatever the force is, okay, so this 3 distance is only going to collect 1 piece of what this collects. So whatever this little piece of distance, this motion has, this one's going to have 1 more of whatever it is we're adding, right? So it's not 9.8 because we're not using full seconds. So it's some tiny, tiny, infinitesimally small number because, you know, obviously we're not going full seconds. But I fixed that here. But anyway, the point is that what you can establish is, let's say this was 500 miles an hour for V1, right? What's the difference for this whole hunk of distance here? Well, the difference is just 1 unit of 9.8, so it's just going to be 500 plus whatever the question mark is of the force that's pushing it. But that's all there is. There's just the 1 unit of force. 1 unit hits beforehand and 1 unit hits after. You could theoretically state. You could theoretically understand that we're basically just saying this is the part that gets 1 unit, and there's 1 unit in any previous unit of distance and time. Just have to think. Well, anyway, this part I know is true. If it's going 500, if we know the velocity here is 500, then we know the velocity here, okay, is 500 plus 1 unit of gravitational fun. Yeah. I believe that's the only way that can be interpreted. Well, let's just say for the sake, I didn't go through this, you know, it takes time to do math when you don't do math. But frankly, I just don't think this 1 to 3 thing can be defeated. Yeah, I really don't think it can. All right. So the times have to be the same because this takes the same amount of time as this when you're falling in gravity. So whatever this is, this will take the same amount of time, okay, and the only difference is going to be this, the amount of difference is the speed change. So the 2 times have to equal the same. So anyway, basically the idea would be is you're just going to take V2, which is a little bit faster. It's gaining the 9.8, so it's going a little faster, minus V1, which is this speed. I'm going to just have to multiply that times this in real seconds, in whole seconds. So that's what this does. And you end up with 9.8 probably. Yeah, probably. I think you have to. So, you know, regardless, I think you have to. So any unit of distance can be cut into finding this spot. This spot is half the speed. And so you might have to multiply this times 2. I'm just not sure. But I don't think you do. But anyway. And so you know you can get just 2 acceleration numbers, 2 different velocity numbers, and you know that acceleration will have to be, that difference has to be this number, put into whole units of seconds. All right, so there's my math. Irritating. Oh, take a little pause. All right. The first by taking data from the entire motion and fitting. I guess I can put this on, but I don't know if it'll do you much good. Never mind. The entire motion fitting the position versus time graph to the parabola. So again, I don't, you know, it's good for you, but I don't even need that much data. Just give me something from the falling thing where you have 2 continuous velocities. The velocity this much and the velocity this much right after it. And that should be all you need. And using the coefficient in front of the 1 squared term to get the gravitational acceleration. So your choice. That coefficient must have units of meters per second squared since we multiply it by the squared, by time squared to get the distance in meters. Well, that's your problem. Okay, I mean, I'm just saying that you're saying your math is even dogmatic now. That nobody can write the equation in some other configuration. taking advantage of the fact that it is actually the distance that's quadratic. The time isn't. Now, yes, there's a huge relationship between time and distance. So, you can play the game, but as I pointed out in the video, the real thing that's quadratic is the distance. So if you want to have a right equation, that equation should concede that relationship. Okay, and then for the drop from rest, test using g equals 2 times fall distance divided by fall time squared. So again, this is your choice. Squared in, squared out. Okay, fine. I'm saying there's no such thing as a squared unit of time in the first place. It's not like something quadratic linear, okay, where you're accruing, you're adding more and more to each time there's more because you've already added, and then you added earlier, and you added earlier, and you're accruing something, so now you're stretching it because you're accruing more and more of it. Time doesn't do that. I think this clearly demonstrates that the units are meters per second squared. I don't think it does anything of this kind. I don't know, frankly, Newton didn't believe in 1/2 mv squared. It's a fact. Now, I don't think Newton used the squared seconds when he calculated the number. So maybe you could show where Newton used squared seconds to calculate 9.8 meters per 1 second. But I don't think he did. Since we use distance divided by a time squared in both cases, but you obviously disagree. Yeah, I disagree. It's not the only way to do the math. And the other way to do the math, it might be more accurate, okay? And it certainly would be more accurate if it acknowledges the truth that what's quadratically increasing is the distance. I'll say it again and again and again, because you completely ignored it. It was in my response, and you've completely ignored it. You now have an opportunity to demonstrate your position. I don't have to demonstrate it. I've already done a 5-minute video on gravity, and I've basically begged you to point out where there's an error in it, and you won't do it. I've explained 9.8 meters. It's 9.8 meters per single second. You're in the gravity 2 seconds, you get 2 units of force. You don't get 4 units of force. All right, I've explained that. I've stated that. That position is my position. Your obligation is to say how I'm being unreasonable to believe gravity is a time-dependent force, not a distant relevant force, a time-dependent force. You don't get 3 units of force traveling these 3 units of distance because it's only 1 unit of time. Now, I've stated that over and over again, and there hasn't been a single rational response explaining how any of those arguments I have made are incoherent, or irrational, or sloppy, or stupid. Nothing. I have told you I will pay you to play the 5-minute video where I'm explaining 9.8 meters per 1 second. And explain how anything stated in that video is incorrect. Alright, anyway. Alright, you now have an opportunity to demonstrate your position. Since this is such an obvious experiment, again, it's an irrelevant experiment. You're just saying, oh, well, let's collect 2 data points. Fine, I'll collect any 2 too. You collect the ones you want, I'll collect the ones I think are more pertinent. Oh, brother. Anyway. That has been done for hundreds of years. Exactly. So why do you think I haven't already accounted for the experiment? Why don't you? I'm sitting here pointing out to you. Yes, I already know it goes half the speed here. Not in the middle, here. Now, have you pointed that out? Have you stated that to your viewers? Well, viewers, you should pay attention to the fact that it's going half the speed after traveling 1/4 of the distance. That's right. In the first 1/4, it gains as much velocity as it gains in the whole 3/4 that follow. The whole 3/4 that follow, it only gains 1 more quarter of real distance and real velocity. I mean, in the sense of more and more unit of real velocity. All right. Okay, if G, so he puts this in capital. If G is measured in meters per second, I couldn't give a poop. It's a frickin' fraction, frankly. And yes, it's 9.8 meters of distance that's been measured in 1 second. Every 1 second you get 9.8 meters of velocity, and in 2 seconds you'll have 19.6. These are the Galilean established facts. So why do I have to argue these established facts? Why do I have to watch your experiment prove something that's already been proven 400 million times? Those are the facts. There's no evidence of anything 4 happening. There's no 4 times the velocity. Okay. There's no obvious indication of 4 times the force. Certainly there's no indication. Twice the speed, twice the time, twice the weight. Not really an indicator of 4 times the force. But you ignore my arguments over and over again and just type this pretentious, bold crapola. All right, measured in meters per second. You should be able to demonstrate a method where you can measure the value of g by just using some distance measured from the data divided by some time value. Yes, just measure 3 units, 3 places. Measure the velocity from here to here, and then the velocity from where you stopped to 3 times the distance. And with those 2 numbers, you should be able to calculate the rate at which you're acquiring the force. All right. Let's see. Demonstrate a method where you can measure the value of g by just using some distance measured in data divided by some time value. That does not get squared at any point. That's right, no squares required. That is measured from the data, which would give us g in meters per second. Yeah, I could put the meters. The meters are in the velocity, so they're already in there, so to speak. Yeah, so I don't need them. You've already said that your data, that the data looks good. I said the experiment looks good. I mean, certainly it's well filmed. So it should be straightforward to demonstrate this. Maybe it is, but again, is that my obligation to do a math equation? I'm making a logical argument about how gravity works. I really don't care about math. It's not that interesting to me. I want to conceptually understand the physics of the universe. I want to understand its relationships between things. And the understanding that you acquire a unit of force, it gives you a velocity, and now you keep that velocity for an eternity, maybe. So every time something gains the 9.8, it keeps it. It doesn't get bigger, it doesn't get smaller. It just keeps it unless some force stops it from keeping it. And that's all it keeps, though, is 9.8 each time that happens. And then when it's going 19.6, that's all it's going, is 19.6. It's not going 40. No, it's going 19.6, and it keeps the 19.6 until something takes it away. And then the 3rd second, it gains another 9.8, and then it's going 29.4, or something like that. That's the truth, and it's a truth you won't argue. Those are the facts, the physical, environmentally consistent and real facts about how the thing works. All right, anyway. Divided by some time value that does not get squared at any point. That is measured from this data, which would give us g in meters per second. You already said that the data looks good. Sorry. So it should be straightforward to demonstrate this. The method should not be dependent on any one particular lucky data point. For example, in my method, I could take a different specific set of data points from the experiment graph or data and get very similar value for g in the drop test. Yeah, go ahead. Take any piece of the falling data and just give me those two accelerations, continuous accelerations, 2 next to each other. One unit of distance, 3 units of distance. All right, drop test. I could use a different fall distance and that fall time to measure the same value of g, which I did. And so again, I guess I could do that also. I'm just saying that obviously, well, it's not obvious to you. It's obvious to me, okay, that all that can change is, all you can acquire in this distance is that half unit of gravity, right? Because this is the full unit. Let's see, wait, no, it's 9.8 per, so it really should still work, yeah. I'm just quibbling over whether you need to multiply by a 2 or not. I'm just not sure, or divide. Get very similar value for g in the drop test. I could use different full distances and fall times to measure the same value g, which I did. The method also should not need to calculate a velocity. The method also should not need to calculate a velocity from some distance and time. Why not? Why wouldn't you derive the velocity from the data? Isn't that the whole point of having the data, is to figure out the velocity? I don't know. And then divide by another time. Yeah, I'm not interested in doing that, because this again would be meters per second squared. Well, like I said, it's not in my reality. Please demonstrate such a method for measuring g as a quantity in meters per second. Again, I'm not obligated to do anything but point out that the unit number matches, okay, the amount of, yeah, well, I'm not saying that's okay. I'm just saying the velocities are going to be in meters per second. So it's all in meters per second already, and then I'm just going to multiply by something that equalizes the time to whole units. So yeah, there's no squaring of anything. The velocities aren't squared seconds. All right. Please demonstrate such a method for measuring g as a quantity in meters per second. The data is already here. Yeah, I really, you could just make up the data. I mean, frankly, it's 1, 3, 5, 7. You could just make up the data. I could just make up a fake 500 velocity like I just did and state that, well, how much faster can this one possibly be going, right? It has to be going, it has to do something in the same unit of time. So if this is the same unit of time as that, then this has to have that extra little bit of velocity. All right. All you need to do is show your work in giving g in meters per second. If you can't do it, I mean, this is just so bullshit. So if you don't do math, you can't do physics. That's the law. You can't make an argument about waves or particles. You can't make an argument about whether, superposition makes any sense at all. You can't even make an argument about why they haven't redone the Eddington experiment. Again, he hasn't even commented on that statement. I mean, he's one of the guys that looks up into the sky a lot, that kind of physicist. And he can't even be bothered to respond to the pointed accusation that your science is lame as hell because it hasn't redone the Eddington experiment, one of the most famous experiments in the history of physics, gave Einstein all kinds of cred, all right, and you really haven't ever redone it successfully. And you have a perfect opportunity from space, 400 times better resolution, an incredible advantage, 400 times. No eclipse necessary, and they don't do it. Anyway, if you can't do it, then do the intellectually honest thing of admitting that you were wrong. I mean, it's just such an outrageous statement. I am not wrong. I defy you to point to one thing in my 5-minute video on gravity. I defy you, okay, to point out my egregious mistakes in pointing out exactly the truth, that gravity is a time-dependent force, okay, and distance is irrelevant. Okay, wrong on this point, and correct your misunderstanding. Just an obnoxious bit of bold type, frankly. Ooh. And he says he doesn't provoke it. He doesn't sit there and cause the tension. Oh, yes, you do, you patronizing, arrogant douche. I mean, I'm just amazing that these people are so full of themselves that they'll talk that kind of shit to somebody else. Ugh, gross. When I'm offering to pay you to take on my argument. Alright, so Brozo comment. He wants to just keep arguing all this old crap over and over, and it's just such a waste of time. But whatever, we'll read some of it and try to get to some of these points he makes somewhere in this slop. So he says, regarding Ian's comment, when you're going to admit, okay, forget all that stuff. When are you going to stick to the point? So this is just a waste of time. Respond to actual question. Where's the, you haven't, there's no questions. You're the one who hasn't responded to any of the points I have made in any video about anything, how the fucking thing works physically. You have no theoretical explanation how twice the weight is 4 times the energy. It's a silly statement on its face and undefendable as a reasonable statement. Your claim that the tabletop launch decides things once and for all. So again, this nonsense about how I pointed out in an experiment, if you get something going twice the velocity and you launch it off of a surface, there's no way it can't. It has to. It's going twice the velocity. It has to fall at the same rate. It has to go twice the distance. Obviously, you're not launching it at twice the velocity. That wasn't my test, retard. Oh, god damn. There's lots of ways you can give something twice the velocity. You could have guaranteed twice the velocity by knocking them off with a pendulum or doing lots of other ways of hitting the ball and making it go twice as fast. You didn't do that. You used some stupid solder sucker as a launcher and then claimed it worked perfectly. Well, I'm claiming it works like a piece of shit. And that it came out exactly 1.4, no point. Your low mass elastic band quick release. So again, the difference between a mechanical and a quick are not necessarily the same thing. Your switch to spherical masses. I don't even know what all this crap is. Yeah, so I rolled balls down a rail, okay, and I didn't come anywhere near 1.4. I didn't get 2 either, twice the speed, but it certainly wasn't 1.4. When are you going to do that? I'm not going to do any of this crap, okay? There's a whole bunch of experiments. Let's go through, what I have shown over and over and over again. All right. Putts, jerk. And you have nothing to say on any of these subjects. I mean, absolutely nothing. You have no response, nothing. No theory, no anything explaining how it works. Nothing. I don't know how the gain got so high. Anyway, all right, so I showed a lever, okay? So suspended, okay, weights hanging below, not above. So just to be clear. So it worked as a balance. And I showed a 4 mass and a 1 mass. And I showed this moving 4 times the distance, the speed, that this moved. And that at any point I could stop that lever and this thing would fly off, theoretically, with 4 times the kinetic energy. When no, okay, doesn't have that, all right? It's just 4 times the velocity and 1/4 the mass. It's just the same momentum. Then the coupled oscillator, okay, pretty visually demonstrated that the motion moves from one side to the other side. The 2 mass moves half the velocity of the 1 mass, half the distance in the same time, blah, blah, blah. Then I did the catapulting thing myself, okay, and frankly, the video almost speaks for itself instead of the fact that this obviously goes a very long distance compared to this. And they both return at the same time, crossing the same line at the same exact time, indicating that this has to be going just about twice as fast because it went just about twice as far. So yeah, with those experiments in the box, okay, plus Gosling's imaginary experiment that he did that we didn't get to see, where the half mass from 4 times the distance crushed the clay exactly the same amount as the 2 mass from 1/4 the distance. I don't have to draw your conclusion because there's plenty of evidence. Mythbusters, car crashes, lots of conflicting evidence. I have no reason to believe your silly, dirty, stinking, flimsy, often poorly constructed experiments are all there ever needs to be seen by humanity. Anyway, when are you going to respond to Ian's actual question? What question? If you insist on straw manning, so again, another lame cry about some sort of straw man when I'm the one making the 5-minute videos pointing directly to the accusation I'm making and stating to you plainly, point out the sentence in the video that's incorrect, and you don't have the guts or the integrity to do that. All right, with a completely different experiment I've already acknowledged was flawed due to the half-mass skidding. So again, You have no proof that the full mass actually was rotating at the speed that it was consuming very much of the total energy, because its rotational speed was much below its longitudinal speed. It wasn't rotating, making full contact with the ground. It was also skidding. All right. I.e. going faster due to lack of friction with the glass surface. Blah, blah, blah. Then when you're going to admit it. Admit what? You have no evidence that it was enough energy to possibly account for the huge difference. Mindless Marvels already showed you closer to 2-to-1 claim is untrue. That it was bang in the middle. Well, so again, this is another one coming from such a liar, right? You have a video posted where you're claiming victory, that you claim something matched your prediction when no, it was right dead in the middle. And you call that a victory. Just like Ian Gosling leaves videos up where he's saying he proved something, and no, he didn't prove anything except he didn't know how to do experiments. He doesn't know how to count to 4. So fuck you and this bullshit. You're the one with the outrageous, exaggerated titles, the exaggerated claims, And clearly the point is when I'm saying 11 and 19 is close, I'm talking about the margin of error. If we just have a 10% margin of error, well, then we have 10 and 20. So you don't even understand those concepts. All right. I do cherry pick the worst numbers. Oh, fuck that. You cherry-pick the worst version of the experiment. I played whatever I could find of the stupid experiment. You film it in garbage vision. It's all a bunch of jump cuts. There's pause this, pause that, slow, fast, this, jittery, chittery, shittery all over the place. Your videos are a fucking mess. The one you even acknowledge is flawed due to the skidding of the half mass. Yes, I'm the one who pointed it out. Okay, yes, I'm the one who pointed out that, hey, look, the yellow one isn't rotating at all. So, yeah, I'm not afraid of that fact, shithead. And that skidding can only make it go faster, not slower. Yes, I pointed that out. But it's still not enough. That the subsequent version of the experiment came out exactly 141. So again, I don't even, 1.4 to 1. So again, we already know that the second version you did of it was retarded because you fucking don't know what angular rotation and momentum is. So fuck you. All right, that me employing a solid 1 mass below half mass does not explain this result otherwise. I don't even know what that means, but obviously it's a pretty stupid mistake to make. You can't say the two things you're comparing. You only have one variable. The only variable you want is the one you're trying to isolate. You don't want some other variable in the experiment, retard. All right, when I repeat the experiment a third time using all solid masses, well, it depends on what you will do. As I pointed out before, you're not going to do something better than your billiard ball experiment. You're going to do something worse. Okay, and so far, exactly what you're doing. You're trying to force the experiment to come out your way. You're not trying to find the best solution. I mean, obviously, billiard balls on glass sounds pretty good. I would say pendulums are even better. Okay. You should be able to categorically now confirm the result will be 2 to 1. I don't know what you're going to do. I have no clue. What are you going to use? Truck tires? What kind of stupid way are you going to do the experiment to try to fuck it up? Exactly the same as when two objects are launched at the same time off the lever. So you are willing to commit to that prediction. I'm stating to you plainly, I've only said it in what, 150 videos? Yes, I believe levers conserve momentum. All right, I think it's so fundamental. I think that's 500-year-old science at least, maybe 2,000-year-old science, frankly. And I don't think it's broken. I think it's an absolute truth that, generally speaking, levers conserve momentum. I'm willing to commit to predicting another 1.4 result. Whatever. Who cares? Why is this in capital letters? Are you willing to commit to predicting 2.1? Again, why would I change my prediction? Why do you think I have any reason to change it? What's the logic of changing it? You're saying conservation of momentum isn't a real thing in the universe. I'm saying it's something indestructible. If you're not conserving momentum, something's really, really wrong. Because frankly, momentum is everything. when I did the both objects launch simultaneously phase of the experiment, me predicting 2.1 in that case, that shouldn't have come out 2.1. I don't know what you're talking about. Now, if the difference in rotational inertia was significant to affect the results to the extent it would have to, in order to account for your 2-to-1 prediction versus 4-to-1. So again, now I'm just saying, you're going to go back to rolling objects, right? And the whole point I've argued about rolling objects is, well, yeah, the fast one has an advantage. So that's just the truth. So yes, the extra velocity is going to mean there's a little less friction taking energy. So you really have to acquire the velocities right after they leave the lever. You can't let them roll too far. As far as I can measure using 120 frame rate camera, blah, 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 blah. Gary, you're a nice man. Fuck you in the ass till goddamn dead. What the fuck is this shit? I guess I won't even bother reading it because I don't know what the fuck he's talking about. But please understand ours. Oh, this can't be a real statement. I mean, this is so bullshit. Do a lot of charity. It only threatened to hit me over the back of the head with a piece of wood due to frustration. I think you should get what you deserve, you lousy, scummy piece of absolute lying crap. You can't get it any worse than you deserve, you stupid piece of shit. You're such a shit-talking liar. Lying about Hothliday. Hothliday knew me, and I knew Hothliday a lot better than you ever did, fuckhead. Alright, you're just such a little weasel. Alright, please understand ours. Every time you make a prediction, not matter how we test it, it just never comes out. Look, just look at Ryan Gosling's record, for fuck's sake. He made videos making bold claims, proof, right? In each video he just, oh yeah, well, I made a mistake. Oh well, I made a mistake. Oh well, I had to cover up that video because the results came out completely wrong. I mean, it's pathetic. And then you, with these exaggerated titles, you sit there and title your video, make people watch the damn video, and the video proves you can't do the experiment right. But you get an answer that's dead in the middle. I mean, fuck you. Oh, you're just disgusting. I couldn't give a fuck what your name is. But please understand ours. Let's see, we just never come out how you claim, so surely you can understand why some of us are beginning to have a slight doubts that you know what you're talking about. I just couldn't give a shit. I mean, I have given reasons for everything I believe. I explain in detail exactly why I am totally unconvinced. I've explained why I'm unconvinced that it's a wave, not a particle. Why I don't think gravity's a bent geodesic. Why I think it's some kind of real thing, like a photon. I mean, all those things have been explained, you fucking piece of shit. Oh, God damn it. Regarding your response to Michael's, he has to monitor everything. You know, he has to monitor all the other trolls. And, oh dear, well, you misunderstood what Troll A said. So now he has to go defend Michael the retard. Where you say, Brozo's billiard ball experiment, for example, and my own catapult seemed to clearly do better than 1.4 velocity. Exactly. So you're admitting you are... So you're admitting you are content to rely on an experiment that even you yourself concede was significantly flawed, rather than the subsequent version where 1.4 exactly was recorded. So again, there's no subsequent version, okay? It's just a big fat fucking lie. A subsequent version where he can't tell the difference between hollow things and solid things. I mean, it's just idiotic. Why do you prefer to cherry pick experiments where you know perfectly well the result was significantly flawed? And again, how do you not know that your result was significantly flawed? You were using very heavy masses, one of them hollow, one of them solid. Really stupid. What is a weather spring, by the way? I don't know what that is. You have to educate me on this. I don't know. I mean, whether you use a spring, so I don't know where he's complaining because it's the wrong weather. Oh man, I mean, you know, spelling errors, so fucking important. Well, I'll have to refresh my memory on your catapult experiments. I don't recall any of your experiments reliably demonstrating what you claim. I mean, the last one is kind of obvious. I also did a different experiment today. So simple, right? You just take the lever, and you put a rubber band here, and then you put a rubber band here, right? Twice the distance. And the funny thing is, it turns out, exactly the 2-to-1 relationship. So this rubber band stretches, let's say 5 centimeters. Let's say the original rubber band is 3 centimeters. This one stretches to 5 centimeters, this one to 4 centimeters, right? 2-to-1. So I'd like to try it at different, 4-to-1 and see if I can get that to be likewise consistent. But, so far, but yeah, that's so simple in terms of showing the difference. But that one, they probably admit that happens. But somehow, again, they think that a half mass is harder to push for some fucking magical reason. The universe can't deal with lighter things. Even though lighter things come out of guns really easily, somehow the universe hates pushing lighter things. Oh, it's just so tedious. And it's gotten hot as hell in here. All right, anyway, for a basement, what is it, 81? Yeah, it's pretty warm. 80% humidity, no doubt. Anyway, so till the next time and such and so forth. Look how dark this got. That damn light, I guess. I have to make sure I leave a light on. Come on, turn on. Now there's plenty of light. All right, anyway. Enough of a video, I'd say. Over an hour. Well, whatever. Till the next time and such. But yeah, I really don't want to do this text thing, bantering back and forth. We've already stated all of these points. Until there's better evidence, you're not convincing me, all right? And frankly, you don't have any theory. There's no theory. 2 units of force can't be 4 units of energy. It's silly.